Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Applications of derivatives. Subtopic Increasing and decreasing functions. Exercise 6.2. Increasing and decreasing functions. What is an increasing function? A function f is an increasing function in the interval I if x1 is less than or equal to x2, implies f of x1 is less than or equal to f of x2 for all x1, x2 belongs to the interval I. f haiba function asi I haiba interval asida increasing oi haigani. I da yauba any x1 amasung x2, x1 na x2 dagi pikpa natraga manaba khudingi f of x1 na f of x2 dagi pikpa natraga manaba sibu chumlabadi function ado I hariba interval asida increasing function kawi. A function f is a strictly increasing function in the interval I if x1 is less than x2, implies f of x1 less than f of x2 for all x1, x2 belongs to I. f haiba function asi I interval da strictly increasing function haigani. x1 na x2 digi pikpa khudingi f of x1 na f of x2 digi piklaba for all x1, x2 belongs to I khudingi chumlabadi strictly increasing function kawi. A derivable function fx is increasing in the open interval I if f dash of x greater than 0 for all x belongs to I. f haiba derivable noiba function asi open interval I the increasing oi haigani. f dash of x always greater than 0 for all x belongs to I chumlabadi. As in picture asida ajik erona represent erona tak liba si y equal to f of x y equal to f of x function amagi graph ni aduga sina y axis ni sina x axis ni x1 x2 x3 x4 sing asi positive direction da laiba number sing ni x value chakot lakwa matamda function f of x1 gi high ordinate value siga ordinate at x2 gi value siga ani si x1 ga x2 ga x2 na sawi function values dasu f of x2 na sawi hojik yek liba graph ase si gi function ase increasing oi amuksu x3 ga x4 ga di x3 dagi x4 na sawi aduba function value ani manai masi pawba da increasing singi asumna aikoina sum kakhat khraga di asum x value chakla graph se parallel oiba mana traga ka wangkhat khraga di aikoina increasing function kawi aduga f haiba derivable function asidi mahakidi f dash s greater than 0 haibadi increasing function amagi point amada singba increasing function amagi point amada singba tangent ki slope si matam pumnamakta positive oigani maramdi mahakna x axis ki positive direction na semi angle theta ase magi inclination na se always positive orabani tan of an acute angle the positive f dash x adi tan theta gumbani adana mahakti matam punamakta positive oigani. Similarly, a function f is a decreasing function in the interval I if x1 less than or equal to x2, implies f of x1 greater than or equal to f of x2 for all x1, x2 belongs to I. f haiba function asi I interval da decreasing function ne haigani. x1 na x2 dagi pikpa natraga manaba khudingi f of x1 na f of x2 dagi sauba natraga manarabadi for all x1 x2 belongs to I gi condition sigi condition sing to chumabadi f haiba I interval na decreasing oiba function kawi. A function f is a strictly decreasing function in the interval I if x1 less than x2, implies f of x1 greater than f of x2 for all x1 x2 belongs to I. f haiba function asi I interval da strictly decreasing function kawe. x1 na x2 dagi pikpa khudingi f of x1 na f of x2 dagi chaurabadi x1 amasung x2 do I interval dagi lowning value logadabare. A derivable function f is decreasing in the open interval I if f dash x is less than 0 for all x belongs to I. f haiba function ji I open interval da decreasing haigani mahaki derivative ki value do matam punamakta less than 0 or negative oiraba for all x belongs to I amagi. As in this picture asida yengsi picture asida function ase y equal to f of x function adugi graph ni graph ase asum sum s ki value chakho laga asum sum name dharai x1 ga x2 ga x2 na sawi number dadi but ordinate at x1 ki value the height sini ordinate at x2 ki value the height sini height dadi x1 f of x1 na sawi f of x2 dagi x1 x2 dagi picture abasu asumna amuksu f dash x haibadi in decreasing curve amagi any point da singba tangent na any point da singba tangent ki any point da singba tangent na positive direction top x axis ki anti-clockwise on the angle at the 90 degree sawi 10 top f dash x adi 10 theta haibani 10 top inclination theta sini 10 theta di 90 degree sawi angle amagi 10 ni negative ni madubuni f dash x less than 0 harisi decreasing curve amagi any point single tangent gi inclination si matam pumna makta 90 degree saugani haiba obtuse angle oigani haiba. A function f is said to be monotonic function if it is either increasing or decreasing function in the interval. Karigumba f haiba function ama monotonic function ni haigani apiba interval amada mahak ase increasing oibama nataga decreasing oibama hold interval aduda increasing pull up oibama madu monotonic function or hold interval to the decreasing loina oirabadi madu monotonic function kawai. Exercise 6.2. So question number 1, show that the function given by f of x equal to thrice x plus 17 is strictly increasing on R. P by f haiba function is a set of real numbers that strictly increasing oigani utlu haibani. Here f of x is thrice x plus 17 whose derivative let x to n y belongs to R such that x is less than y. Then 3 na both sides multiplied the inequality remains unchanged. 17 adding to the term both term animal we get this, which is what? This is the value of f of x. This is also the value of f of y. Thus x is less than y implies f of x is less than f of y. There is no equal to sign in both. Thus f of x is strictly increasing function on R. For question number 2, show that the function given by f of x equal to e to the power twice x is strictly increasing on R. We have to show that this function is also strictly increasing on the set of real numbers. For this, f dash x is 2 times of e to the power twice x whose derivative is this, which is always greater than 0 for all x belongs to R. Thus, f of x is a strictly increasing function on R, the set of real numbers. For question number 3, show that the function given by f of x equal to sin x is strictly increasing on 0 to pi by 2, strictly decreasing on pi by 2, pi by 2 to pi, neither increasing nor decreasing on 0, 0 pi open interval. Here f of x is sin x whose derivative is cos x which is greater than 0 for all x belongs to 0 to pi by 2. Implies f is strictly increasing on 0 pi by 2. Again f dash x is cos x which is less than 0 for all x belongs to pi by 2 to pi. As in this picture 0 dagina pi by 2 power the function is increasing or pi by 2 dagina pi power the function is decreasing or masi kana ki cup no y equal to sin s ki cup ne. Implies f of x is decreasing in open interval pi by 2 to pi. We see that f dash x is greater than 0 in 0 to pi by 2 open interval and f dash x is less than 0 in open interval pi by 2 to pi. So f of x is neither increasing nor decreasing on 0 to open interval 0 pi. 0 pi asida function na se partly increasing partly decreasing whole the interval da amakaktamak chumba oidre aduna masi neither increasing nor decreasing ore. Question number 4. Find the intervals in which the function f given by f of x equal to twice x square minus thrice x is strictly increasing, strictly decreasing. F haiba piba function asibu strictly increasing oiba intervals putu, strictly decreasing oiba intervals putu. Here f of x is twice x square minus thrice x, whose derivative is 4x minus 3. Taking out 4, we get this, which is always greater than 0 if x is greater than 3 by 4, and whose value is always less than 0, that is negative if x is less than 3 by 4. Therefore, f of x is strictly increasing in the open interval 3 by 4 infinity, and is strictly decreasing in my open interval minus infinity 3 by 4. For question number 5, find the intervals in which the function f given by f of x equal to this is strictly increasing, strictly decreasing. Here f of x is this cubic function. Its derivative is 6x square minus 6x minus 36. Taking out 6 and factorize the quadratic, we get this. Now f dash x equal to 0. We have to put f dash x equal to 0, and solving we get x equal to 3 or minus 2. The number line is divided by these two numbers in 3 domains. When x is less than minus 2, f dash x, when x is a number less than minus 2 in the above f dash x, we get this is plus, this is minus, this is also minus. Product of these three numbers is always positive, greater than 0. Similarly, x is lying between minus 2 and 3, and the sign of f dash x is, which is plus, this is minus, this will be plus. Therefore the product of the three is minus, which is less than 0. Similarly, when x is greater than 3, the sign of f dash x is plus, which is plus, we get plus, which is greater than 0. Thus f is strictly increasing in what? Increasing in open interval 3 infinity and open interval minus infinity minus 2, and strictly decreasing in minus 2 open interval minus 2 3. For question number 6, find the intervals in which the following functions are strictly increasing or decreasing. For A, here f of x is x square plus twice x minus 5, whose derivative is this. Factorizing, we get this. For f of x to be strictly increasing or strictly decreasing, we have to put f dash x equal to 0. Solving x, we get x equal to 1. This number divides the set of real numbers into two open intervals when x is less than minus 1. If x is any real number less than minus 1, the sign of f dash x, is negative, that is less than 0. And when x is any real number greater than minus 1, the sign of f dash x is always positive. From this, we conclude that f of x is increasing in minus 1 infinity and strictly decreasing in minus infinity minus 1. For B, f of x is this, whose derivative is minus 6 minus 4x. Factorizing, now f dash x equal to 0 gives x equal to minus 3 by 2. This real number divides the set of real numbers into two open intervals. The first one is when x is less than minus 3 by 2. If x is any real number less than minus 3 by 2, the sign of f dash x, is always greater than 0, positive. And when x is any real number greater than minus 3 by 2, the sign of f dash x is less than 0, From this we conclude that f is strictly increasing in x less than minus 3 by 2 and strictly decreasing in x is greater than minus 3 by 2. For C, f of x is this, whose derivative is minus 6x square minus 18x minus 12. Factor taking out minus, and we get this, factorizing. Now f dash x equal to 0 gives x equal to minus 2 or minus 1. These two numbers divide the set of real numbers into three domains, three open intervals. When x is less than minus 2, the sign of f dash x is negative. When x is lying between minus 2 and minus 1, the sign of f dash x is always positive. When x is a real number greater than minus 1, the sign of f dash x is always negative. From these three reasons, we conclude that f of x is strictly increasing in open interval minus 2 minus 1 and strictly decreasing in open interval minus infinity minus 2 and minus 1 plus infinity. For D, here f of x is 6 minus 9x minus x square, whose derivative is minus 9 minus twice 6. Now we have to put f dash x equal to 0. This gives x equal to minus 9 by 2. This real number divide the set of real numbers into two open intervals. When x is less than minus 2 by 2, the sign of f dash x is always positive. When x is greater than minus 9 by 2, the sign of f dash x is negative. Thus, f of x is strictly increasing in x less than minus 9 by 2 and strictly decreasing in x greater than minus 9 by 2. For E, f of x is this. We have to differentiate whose derivative is this. Factorizing, we get this. Put f dash x equal to 0, solving x equal to minus 1, 1, 3. These three numbers divide the set of real numbers into four domains. When x is less than minus 1, the sign of f dash x is negative. When x is lying between minus 1 and 1, the sign of f dash x is also negative. When x is lying between 1 and 3, f dash x is always positive. And when x is greater than 3, f dash x is also positive, that is greater than 0. Thus, f of x is strictly increasing in 1, x is lying between 1 and 3, and x is greater than 3, and strictly decreasing in x is less than minus 1 and x is lying between minus 1 and 1. Question number 7. Show that y equal to log of 1 plus x minus 2y x by 2 plus x, where x is greater than minus 1, is an increasing function of x throughout its domain. Here y equal to this, and whose derivative, if y is equal to f of x, then whose derivative is 1 by of 1 plus x, and whose derivative is, apply quotient rule, we get this. Simplifying, we get this. Again, let us simplify, we get this. Since x is greater than minus 1, x plus 1 is always greater than 0. It is positive. Also, x square and 2 plus x square greater than 0. They are positive numbers. This is positive. Quotient of 2 positive is again positive. Therefore, f dash x, the sign of f dash x is positive if x is greater than minus 1. Hence, f of x is increasing throughout its domain. Find the values of x for which this is an increasing function. Find the values of x for which this is an increasing function. Here y equal to x times of x minus 2 whole square, and expanding squaring we get this, and expanding we get a polynomial in x. Let f of x denote this function whose derivative is 4x cubed minus 12x squared plus 8x. And factorizing, taking out firstly common factor for x, we get factorized the quadratic factor, we get this. Now f dash x equal to 0 gives this, which equal to 0. This gives x equal to 0, 1, 2, 1, 2, 0, 1, 2. These three real numbers divide the set of real numbers into 4 domains. When x is less than 0, the sign of f dash x is this is plus, this is plus, this is negative, this is also negative, this is also negative. X is less than 0. Then product of three negatives is negative, that is less than 0. When x is between 0 to 1, then the sign of f dash x is plus, plus, minus, minus. We get product of two minus is again positive, that is greater than 0. When x is lying between 1 and 2, the sign of f dash x is this is plus, this is plus, this is minus, this is plus. Then product of only one minus is minus, which is less than 0. When x is greater than 2, the sign of f dash x is always plus. From this we conclude that f of x is increasing in the interval. F of x is increasing in the interval that is 0 to 1, whose upper interval is this, and from x greater than 2, whose upper interval is this. We have to find out the values of x for which the function is increasing. Prove that y equal to this function is an increasing function of theta in this closed interval. Prove that this function is an increasing function of theta in this closed interval. Let us prove. Y is this. Let this y denoted by f of theta, we get this, whose derivative is, applying quotient rule in the first term, we get this. For last theta, its derivative with respect to theta is 1. Simplifying, we get this. When theta belongs to closed interval 0 pi by 2, it means an acute angle, the sign of f dash theta is always positive. This is positive, this is also for minus cos theta is also positive, cos theta is also positive. Product or quotient of positive is again positive. The sign of f dash theta is greater than 0. Therefore, f of theta is increasing in the closed interval 0 to pi by 2. For question number 10, prove that the logarithmic function is strictly increasing on open interval 0 infinity. Let us prove. Here f of x is log x. This function is called logarithmic function, whose derivative is log x, whose derivative is 1 by x. When x belongs to open interval 0 to infinity, the sign of f dash x is always greater than 0. Therefore, f of x is strictly increasing in the interval 0 infinity. We have drawn the graph of y equal to log x, which is always increasing function. As per Pen, prove that the function f given by f of x equal to x squared minus x plus 1 is neither strictly increasing nor strictly decreasing on the open interval minus 1 to 1. Let us try. Here f of x is equal to this, whose derivative is twice x plus minus 1. Now we have to put f dash x equal to 0 gives x equal to half, which divides the set of real numbers into two domains. We have two intervals minus 1. This half divides the open interval minus 1, 1 to two domains, that is minus 1, half, and half 1. When x belongs to the first open interval f dash x, the sign of f dash x is negative. When x belongs to the second open interval f dash x is positive. Therefore, f is strictly decreasing in minus 1, half, and strictly increasing in the open interval half 1. Thus, f is neither strictly increasing nor strictly decreasing on open interval -1, 1. For question number 12, which of the following functions are strictly decreasing on 0, pi by 2? Cos x. Here f of x is cos x, whose derivative is minus sin x, which is less than 0 for x belongs to 0 to pi by 2. If x is an acute angle, sine of an acute angle is positive, minus of a positive is always minus, that is less than 0. Therefore, f of x is strictly decreasing on the open interval 0 to pi by 2. For b, here f of x is cos twice x, whose derivative is minus 2 sine of twice x less than 0 for x belongs to 0 to pi by 2. Therefore, f of x is strictly decreasing on the open interval 0, pi by 2. For c, f of x is cos of thrice x, whose derivative is minus 3 sine of thrice x. Now, f dash of x equal to 0, which gives sine of thrice x equal to 0 gives thrice x equal to 0 pi, implies x equal to 0 or pi by 3. Therefore, x can take pi by 3 because x cannot be 0. Therefore, we have to take x equal to 60. When x is lying between 0 to pi by 3, that is x is lying between 0 to 60, then the sign of f dash x is always less than 0. When x is lying between pi by 3 and pi by 2, the sign of f dash x is always positive. Therefore, f of x is strictly decreasing on the open interval 0 pi by 3 and strictly increasing on pi by 3 pi by 2. The f of x is 10x, whose derivative is sec squared x. When x belongs to 0 to pi by 2, f dash x is always greater than 0. Therefore, f of x is strictly increasing on the open interval 0 pi by 2. For question number 13, on which of the following intervals is the function f given by this strictly decreasing? 0 to 1, pi by 2, 2 pi, 0, pi by 2, none of this. Let us try. Here f of x is x to the power 100 plus sine x minus 1, whose derivative is 100 times of x to the power 99 plus cos x. When x belongs to 0 to 1, then whose value is always plus, cos x is also positive. Sum of two positive is positive, therefore the sign of f dash is positive, that is greater than 0. Therefore, f of x is strictly increasing in the open interval 0, 1. For b, when x belongs to pi by 2 to pi, then the sign of f dash x is greater than 0. Therefore, f of x is strictly increasing in the open interval pi by 2 to pi. For c, f of when x belongs to 0 to pi by 2, f dash x its sign is positive. Therefore, f of x is strictly increasing in the open interval 0 pi by 2. Thus, the answer is D. For question number 14, find the least value of a such that the function f given by f of x equal to x squared plus ax plus 1 is strictly increasing on open interval 1, 2. Here f of x is x squared plus ax plus 1, whose derivative is twice x plus a. But x is lying between 1 and 2. Multiplying on in its term by 2, we get this. And adding a in its term, we get this. And the f of x is strictly increasing in the open interval 1, 2. If twice 2 plus a is greater than or equal to 0. That is, a is greater than equal to minus 2. Therefore, 2 plus a equal to 0 gives a equal to minus 2. Thus, the least value of a is minus 2. The required least value of a is minus 2. For question number 15, let I be any interval disjoint from -1, 1. I is also an interval which is disjoint from the interval -1, 1. Prove that the function f given by f of x equal to x plus 1 by x is strictly increasing on I. Let us prove. Here f of x is equal to x plus 1 by x, whose derivative is 1 minus 1 by x square. Sum up, we get x square minus 1 by x square. Now x does not contain in -1, 1. That is, x is less than -1 or x is greater than 1 is in this picture. Then squaring on both sides, we get x square is greater than 1, or implies x square minus 1 is greater than 0. Therefore, f dash x is greater than 0. Therefore, f of x is strictly increasing on I. F of x is strictly increasing on I. Hence proof. Question number 16. Prove that the function f given by f of x equal to log of sine x is strictly increasing on the open interval 0 pi by 2 and strictly decreasing on pi by 2 pi. Let us prove. Here f of x is log of sine x, whose derivative is 1 by sine x into cos x, that is cot x. When x belongs to open interval 0 pi by 2, then f dash x is sine, whose sine cot of an acute angle is always positive. Therefore, f dash x is greater than 0. When x belongs to obtuse angle, this open interval, f dash x is less than 0. That is, cot of an obtuse angle is a negative. Therefore, f dash x is less than 0. Therefore, f is strictly increasing on the open interval and strictly decreasing on this interval. Hence proof. Question number 17. Prove that the function f given by f of x equal to log of cos x is strictly decreasing on this and strictly increasing on this interval. Here f of x is log of cos x, whose derivative is 1 by cos x into minus sine x, that is minus 10x. When x belongs to open interval 0 pi by 2, f dash x is negative, and when x belongs to pi by 2 pi, then the sign of f dash x is positive. Therefore, f is strictly decreasing on open interval 0 pi by 2 and strictly decreasing on pi by 2 pi. Question number 18. Prove that the function given by f of x this is increasing in R. Here f of x is equal to this polynomial, whose derivative is this, and taking out 3 and factorizing the quadratic factor, we get this, which is always greater than equal to 0 for all x belongs to R. Hence, f is increasing in R, the set of real numbers. For question number 19, the interval in which y equal to x square into e to the power minus x is increasing is, here y equal to this, whose derivative with respect to x is denoted by dy by dx, whose derivative applying product rule, we get first function x square remains unchanged, derivative of second function is this, and plus second function remains unchanged into derivative of first function, there x square, for x square it is twice x, and factorizing we get this. Now we have to put dy by dx equal to 0, that is this equal to 0, solving x equal to 0 or 2, which these two numbers divide the when x is less than 0, the value of dy by dx is negative. Therefore, y is decreasing x less than 0. When x is lying between 0 to 2, dy by dx is always positive. Therefore, y is increasing in 0 2. When x is greater than 2, the sign of dy by dx is negative. Therefore, y is decreasing in x greater than 2. Your correct answer is 0, open interval 0 to, that is the